On this video, we're going to be looking at the various methods that firms can produce stuff and how they can measure how efficient they are and how productive they are, and look at the different methods, different mixes between labour and capital. An obvious example of the transformation process will be when you make a cake. So you start off with bits of ingredients, perhaps bits of fruit, some flour, some sugar and other stuff. You then mix it all together. You then put it into the oven. When it comes out, you then might want to add bits to the top of it. So you start off with gunk and you finish up with a lovely cake. So that is the transformation process. There are four methods of production that we need to know about. Those are job production, batch production, flow production, and cell production. Job production is where you're producing a one-off item for an individual customer. So you can see there is a swan-shaped yacht that some idiot decided that they'd like to spend their spare time in. Look at something like the O2. There's only one O2, or Wembley Stadium. So this is something very specific for an individual. Now, the thing about job production is that it's relatively cheap to start the process, to set up, but it tends to be more expensive overall to produce a thing because you're producing something specific for an individual. It lets you offer a specialist type service. Obvious examples will be tailor-made clothes as opposed to clothes off the peg, specialist cakes like we saw recently, and a particular web design for your company. As you can imagine, job production, the final product, tends to be more expensive than the other methods because you're making something specific for an individual. With batch production, you're producing identical items in a batch, and each item passes through the production process at the same time. Like you can see those donuts going through there. It's faster and cheaper to produce them rather than producing individual units. The products tend to be more uniform. You might have a little bit of variation between batches. And examples there would be how bread is produced, jeans, garden furniture, or students. So each year we'll put through batches of students into individual classes, and the following year we'll have a different batch to work with. Flow production tends to be mass production. It's where the production line is continuous. It's for large scale production where you're producing broadly identical items. You're likely to have specialist machinery, so you can see the robots there. Workers typically are responsible for a very small step of the process. They tend to be specialists, and for economists among you, they tend to employ division of labour. So what are the pros and cons of flow production? Well, it tends to be more efficient if you are producing a lot of output. Your unit costs tend to be lower. Your quality tends to be more consistent than when you've got an individual producing, say, a job for someone specific. And it does involve less need to hold stock because you know what you're going to be producing, whereas with job production, you don't know exactly what you're going to need because it's going to differ from person to person. However, the initial costs are very, very, very high. Typically, you're going to have computerization or robotization. You're going to need a lot of machinery, and your staff need to be highly trained. And the thing about job production is that if you have a mistake anywhere on the production line, it will shut down that entire production line. The job tends to be quite boring for workers. You know, perhaps they're riveting on the same part on the same car day in, day out. They tend to be less motivated if you're designing something from scratch, and the products tend to be quite standardized. Not always so. With cars, for example, at the last stage of the process, you can say what types of seats you want, but typically with flow production, it tends to be a pretty standardized sort of product. One that's slightly more complex is cell production, which is a form of flow production, sort of. So you divide the production line up into a series of self-contained cells. Now, each cell produces a complete unit of output, and the cell members work as a team, so they're not necessarily stuck to one particular task. They can swap things around, and they also tend to be responsible for their own quality, so it isn't done at the end of the process or by someone else. It's done by the team itself. Hopefully, it should increase quality, teamwork and motivation. But of course, it does depend upon the staff being well trained, because they'll need to know how to do everything in the process. Time for some maths. There are three terms associated with this: production, productivity and efficiency. Production is the total number of units produced in a time period. For example, the number of cars produced per year. Productivity is the output in relation to the inputs in a given time period. So, for example, it could be the output per worker, or the output per worker hour, or perhaps the output per unit of capital that you've got, particularly if you've got robotics. Now, if productivity goes up, that tends to be associated with an increase in efficiency. If we look at the factors affecting capital productivity, well, one is obviously going to be the type of capital that you are working with, the age of that capital, and the amount of maintenance that capital requires. It's going to depend upon the quality of the operators and how trained up they are. The input quality is important. The example I've given there, you could have a high quality printer, but it will stop working if it jams due to you putting in low quality paper. You look at the number of hours the machine is in use compared with the number of hours that it's down, in other words, not in use, perhaps being repaired or maintained. Given that a lot of these machines are actually largely run by computers, the efficiency of the program that's running them and monitoring them is going to be a factor. And of course, it could be affected by unforeseen events like power cuts. With labour productivity, we've got a much shorter list: workforce training, workforce skills and how you utilise those. One of the things about people is that they have to be motivated, whereas a machine is just a machine. A person could work better if they're highly motivated, or they could work badly if they're low motivated. So one of the things that you have to look at is the HR programs and the motivational programs that go on within the organisation, and of course the complexity of the product. So to churn out an A-level student is actually quite a complex task. Well, in terms of increasing efficiency, your aim is to maximise the number of bangs you get for your buck. In other words, to maximise your output from a given level of inputs. And by inputs, we're referring to machinery, materials and people. So how can you do this? Well, possibly you could increase your capacity utilisation. An obvious way of, say, increasing efficiency in this classroom would be to whack in a couple more students, or to increase efficiency in a plane would be to make sure that you don't have as many empty seats. You could make your existing labour more productive. You could try to do that. It may be that you look at the way you do things, whether you employ lean production techniques or not, or whether you employ just in case type techniques. Getting the resource mix right, the right combination of labour and capital, that could be a way of increasing your efficiency. And of course, these days, how well you use your technology could be a way of increasing your efficiency, getting in computers, that sort of thing. Now, in terms of how we can increase labour productivity, which is good if we want to reduce our unit costs, well, again, as we've said, training could be a way of doing it. Trying to look at motivation of workers could be important. So we could introduce a financial reward system, or a non-financial reward system that you would have done on other parts of the spec. How you allocate your jobs, whether perhaps you swap jobs around, whether you empower certain workers or not, that could be important. Again, how those workers use new technology, how they actually work, whether they can improve the way that they do things, better working practices. So for example, Kaizen type techniques that we use increasingly from Japan, or the way that we recruit workers and select workers. So getting the right team in the first place could be quite important in terms of boosting your labour productivity. Unfortunately, with people being people, you're going to have problems increasing your labour productivity. It's possible that you are motivating them perhaps to serve their customers as quickly as possible. Well, that could have a negative effect on quality and customer satisfaction, and that could have a negative impact on your long-term reputation. Or perhaps you could cut down on training because you want to save a bit of money, which means that you are likely to increase your wastage. One other factor is that your employees might feel exploited. You think you're empowering them. They think that they're being given additional stuff to do. Perhaps they're working harder for the same pay while you're asking them to do that. It is possible from that they might become discontented and try to push for higher wages. They might feel that the business is benefiting, but not them. And it may be that they can't cope with the increased workload, and so stress levels go up, demotivation goes up, and the firm might lose out in that way. This final section of the video looks at the allocation of resources between labour and capital. If you are capital intensive, it means that you're very dependent upon machinery. Often in the secondary sector, the manufacturing sector, you get more capital intensive outputs. If you are labour intensive, that means that there are a relatively high number of workers compared with the number of machines. Tends to occur in the tertiary or service sector. So, for example, in teaching or nursing, there are very, very high labour intensive methods of production. So generally, if we have a capital intensive method, you are likely to get higher productivity. You are likely to get improvements in quality and speed. It means that your labour costs are going to go down, and there is more scope for economies of scale if you are capital intensive than if you are labour intensive. The cons, those robots aren't cheap, and so you've got high initial investment to start the system up to get more capital intensive. People might feel slightly more fed up because they're not able to use their initiative as much, and it's possible that they might resist change. For example, they might be happy doing what they've always done for years, so if you bring in new technology, you may well find resistance from your workers if that occurs. Now, with labour intensive production methods, the one big advantage is it is often cheaper, and firms will frequently take advantage of producing outside of the UK, finding a cheap location to do that, for example, India. And the good thing about people is that they can adapt to change, particularly if they are multi-skilled, so you can move someone from one task to another task. So, for example, business teachers will often teach economics. We can teach vocational as well as A levels. And again, because people are people, they're capable of thinking, and so they can think through perhaps better ways of doing things, coming up with new ideas. Machinery can't come up with a new way of doing stuff. And finally, it's possible, not necessarily, but it's possible that the government might provide aid to keep jobs in a particular sector. And one of the things government doesn't like to do, particularly when it's coming into an election, is for unemployment to go up. So that's just a possibility. They're not that bothered really as to whether a machine is redundant or not, because machines don't vote. The cons of labour intensive. Well, the first one is that people can go on strike. Machines can't go on strike. They can go wrong occasionally, but they can't go on strike. You might need certain skilled workers in some industries. So again, you might not be able to get hold of those workers. And the human resource costs are often very high. Recruiting, selecting, training compared with capital intensive methods.